Okay, click the present now screen. Okay, so I hope you can see the screen. Okay, so please let me know if you can see the this PowerPoint presentation.
Yes, sir. We can
Okay,
see.
okay, you can see the PowerPoint presentation. Okay, so this is the today's topic. Okay, so just first of all, we will discuss about a simple theory. What do you mean by centrifugation? If a particle in a suspension is centrifuged with the angular velocity of omega, will experience the centrifugal force, which is given by the following equation. This is the equation. So now we are to understand that what is the centrifugation. So if you just go back to your school days knowledge about the centrifugal force, there are two types of forces. Once you rotate something, so there are two types of forces that act on the circular motions. So one is the centrifugal force, and second one is the centripetal force. So what happens? So something like this, what we can understand is that uh, supposing that you are rotating something in this way, okay. So when you rotate something in this way, so two forces they act. One force, if it is rotating like this, one force will act away from the radius, okay. That force is called centrifugal force. One force is called centripetal force, because when you are rotating this manner, so what happens? One force is just acting in this side, okay. That is called centripetal force. So centripetal force is not the topic of our discussion, because we are mainly interested in the centrifugal force, okay. So this centrifugal force, it will try to force all the particles in the suspension away from the radius, okay. That is what is the centrifugal force. Now, to understand that the centrifugation is done only in case of suspension. It is not done in case of solution. We will discuss it, because I think we have discussed earlier also that suspension, solution, and colloids and suspension, this can be used for centrifugation. You can separate the analytes, okay, using centrifugation only in case of suspension and colloids, not in case of solution. For example, you take the glucose and add it into the water. Glucose gets completely dissolved in the water. If you try to precipitate the glucose using centrifugation, you cannot, okay, because that is a solution. So centrifugation is only done for suspension. The blood is also a kind of suspension. However, the blood is not called suspension, it is called colloid, okay. So if you just see the difference between these three, colloid, suspension, and solution, okay. So when the particle size of a solute, okay, is less than 1 nanometer, it is called solution. Or simply, when the particles are in the molecular form, they are the molecules. So glucose, you take a glucose particle, one glucose particle contains millions of glucose molecules. When you add it into the water, so it gets completely dissolved, it makes a solution. So what happens? All these glucose molecules which were together in the particle, they will separate and they will be in the molecular form. That's why it is the solution. In colloid and suspension, here what happens? The molecules in the particles, they do not separate, they remain together, okay. Now this particle size, it determines whether it is suspension or solution, okay. When the particle size is in the nanometers, that means say something around less than 1 micrometer. So if you see the Wikipedia, it says that colloid is it is a kind of solvent, or it's a kind of this thing where the particle size is less than 1000 nanometer. In simple terms, it is called, but in some people they say that it should be less than 200, 300 nanometer. There are difference in opinion, but it should be less than 1 micrometer. But when the particle size is more than 1 micrometer, so it is called suspension. Okay, so in suspension or in the colloid, only you can precipitate. Okay, so why is it so? We will see in the next slides. Okay, so this is the formula. Okay, you don't have to remember this. So here the F is the centrifugal force, M is the mass, this omega is the angular velocity. That means per hour, how much angle is covered by the centrifuge. That is called angular velocity. And this R is the radius. Okay, so this is what I have already mentioned. Okay. Now, as the particle is not in the vacuum, it will experience a back force.
Excuse me, sir.
Yeah.
Sir, screen is not visible, sir. You have not shared.
Oh, I'm sorry. I think I have not share. Oh, I forgot to share it. I will. Okay. Is it visible now?
Yes, sir,
okay.
It's visible.
Okay. So this one I have already mentioned. Here F is force capital F is equal to mass into omega square R. The M is the mass, omega is the angular velocity, okay, and R is the radius. Okay, this is what I have already mentioned. Okay. Now, as the simple theory is, as the particle is not in the vacuum, it will experience a back force that is called buoyant force. So, buoyant force means here what happens is your particles are in the liquid medium. Say, for example, you are taking the blood, you want to precipitate the blood cells. Okay, so in that case, your blood cells are suspended in the water because blood, in case of blood, the solvent is water. Okay. So when you will do the centrifugation, your blood cells will go away from the radius under the influence of the centrifugal force. Okay, but this force will be opposed by the force of the water, because water will always oppose the centrifugal force. This force is called buoyant force. Okay, so buoyant force will always oppose the centrifugal force. Okay. So as a result, the buoyant force will reduce the velocity of the sedimentation. Sedimentation means the particles that will go away from the radius, and then it will move to the bottom of the centrifuge tube. That is called what we call sedimentation of the particles. Okay. So this is the formula of this V stands for the V. The V is the velocity. Okay, in which the particles will move away from the radius. I mean, it will move away from the center of the centrifugation. That is, it is the speed or it is the velocity in which the particles will move to the bottom of the tube. Okay. So here in this formula, this RP, it stands for radius of the particle. So here just we are assuming that the particle is spherical. Generally, all particles are not spherical. Okay. Then this rho p, here this rho p, this value. So rho p indicates the density of the particles. So every particle, they have got some density. Okay. Then rho m, this value. Rho m is the density of the medium where the particle is suspended. Okay. Say if you take the blood and if you want to precipitate the blood cells, so in that case the water will be the medium. Okay. Then rho m will indicate the density of the medium. Okay. Then omega is this omega. It is, I've already mentioned, omega is the angular velocity of the rotor. Okay. Then eta, this value eta, it is the coefficient of medium where particle is suspended. So this is a constant. Okay. Now let us see in this particular thing. Okay, rho p and rho m. If we just look into only this value, rho p and rho m. Let me open the paint also. Okay. Okay. So this value, I will just take this one here. Okay, and just forget all these things. So what we understand from here is that this velocity of the particles, okay, in which the particle will be, so velocity of the particle, okay, so velocity of the particle is directly proportional to the difference between the density of the particle and density of the medium. Now see why the when you add the glucose into the water, it forms a solution. Now you cannot precipitate glucose. What is the reason behind this? The reason is that, see, rho p is the density of the particle and rho m is the density of the medium. Okay. Now here what happens? The density of the particle is less than the density of the medium. That means density of the glucose molecules, it is less than the water. Okay. So as a result, what happens? If this particular value, if it is more, then as a whole this value will be minus, it will be negative. Then as a whole the velocity also, this value also will be minus. That means the particles will not sediment. Okay. Now another point that you can see over here is that the velocity will increase when this difference will be more. Okay. That means when the difference between the density of the particle and density of the medium is more, so velocity of the sedimentation will be more. Okay. Say for example, when we precipitate DNA, see the DNA, when it is dissolved in water, so what happens? The density of the DNA is less than that of water. Okay. So in that case, you cannot precipitate DNA. Fine. But what is done is that this DNA, okay, in order to precipitate the DNA, what we do, to that solution of DNA, we add alcohol, ethanol. We add ethyl alcohol or isopropyl alcohol. So when you add isopropyl alcohol or ethyl alcohol, so what happens? The density of the medium decreases because density of the water is high, but the density of the alcohol, it is less. So when you add, when you go on adding the alcohol to the this DNA solution, so what happens? The density of the medium decreases. Okay, when this value decreases, so then this value will, it is constant, and this value will be more than this value because this value is decreasing because of addition of the alcohol. So in that case only we can precipitate the DNA. Okay. So those of you who have either minor or supporting, they taken either supporting or minor in biotechnology. So if they have taken any kind of practical course, so you will come across the precipitation of DNA, because when you isolate the DNA, so last step is the DNA precipitation. Okay, because your DNA will be in solution, you have to precipitate the DNA. So to precipitate the DNA, so ethanol, either ethanol is used or isopropyl alcohol is used. Okay. So what is the need of using ethanol or isopropyl alcohol? So their basic aim of using ethanol or isopropyl alcohol is to decrease the density of the medium. Your medium is water. When you add alcohol to the water, the density of the medium decreases. Okay, fine. Now the next thing is, copy this. Copy this once again here. Okay, so this is the thing that we discuss now. Okay, then the next is the,
Excuse me, sir.
Yeah, yes,
Sir, I think the class is not being recorded.
no, it is recorded. I'm using the screen recorder.
Okay, sir.
It is being recorded in my laptop, and thereafter it will be I will make the MP4 file and I'll share that with you. Okay, okay, fine.
Okay, sir.
So this if you see, this RP is the radius of the particle. So the what does it mean is that those particles which are bigger particles, okay, they will precipitate faster than those particles which are smaller in size. Okay, that means if you have a mixture of the particles in your suspension, okay, so then when you will start centrifugation, what will happen? Those particles which are bigger, so big particles means they've got bigger radius, so they will settle down into the bottom of the tube faster than those which are smaller in size. Okay, this is what we understand by this one. Okay, fine. Then the next is the angular velocity, omega square. Okay, so there is a relationship between the this revolution per minute (rpm) and the angular velocity, because because in centrifuge machines you will not find angular velocity. You will always find RPM or RCF. But in our department, we have one centrifuge machine where we have three: angular velocity, RPM, and RCF. But of course, this angular velocity is having direct relationship with the RCF or RPM. Okay, so now what it indicates is that this RPM or revolution per minute or the speed of the centrifugation is directly proportional to the velocity of the sedimentation. Okay, this is understood. When you increase the this speed of centrifugation, so what will happen? These particles will move towards the bottom of the tube faster. Okay, then the next comes is the radius. Okay, so now if you come to our department, you'll find that we have two centrifuge machines. We have not two, we have three centrifuge machines, but the third one I will not talk about. These two we have in the PG lab. So one centrifuge machine, so we have two centrifuge machine. So one centrifuge machine, the rotor is smaller. In another one, rotor is bigger. So big rotor means the radius is big. Small means radius is small. Okay. So what will happen when you use the same speed in this one and this one, the smaller one and the bigger one? So you will find that speed of sedimentation is faster in the bigger one. Okay, and it is slower in the smaller one. Okay, so the thing is that both of the centrifuge machine, you are putting the same speed. Speed is same. Okay, but still in one centrifuge machine, okay, what you are doing is that in one centrifuge machine, your radius is bigger, and here radius is smaller. Okay, now this is where many people they make the mistake. So for example, they use 2000 RPM in the smaller centrifuge machine which we have in our department. Okay, sometimes what happens, they don't need that one. They need or sometimes what happens, somebody else is using that centrifuge machine, so they go to the bigger one, and there they put the same centrifuge speed. So what happens when they put the same centrifuge speed over there? Okay, so what happens? Their sample gets destroyed. Okay, the reason is that because here radius is smaller, so force is, the velocity will be less. Here velocity will be more. Okay, but they think that I'm putting the same speed, so no problem. But problem is there. Okay, so we will discuss about it. Okay. So this is what is the radius. So radius affects radius of the rotor or the centrifuge machine. It affects the velocity of your particles. Okay. Now we'll go ahead. Okay. So we have already mentioned. So this sedimentation coefficient. So I think if you are studying molecular biology, so you must have come across say 16S rRNA, 18S rRNA, 23S rRNA. Okay, what is this S indicates? S indicates the sedimentation coefficient. Okay, so S is also called Swedberg's constant. It is this S is given in the honor of the scientist who given this term, or S is also called sedimentation coefficient. Okay, So now what happens, like you have 16S ribosomal RNA, 23S ribosomal RNA. So the density of the 16S ribosomal RNA is less than the 23S ribosomal RNA. So when you will centrifuge, so what will happen? This 23S will sediment earlier than this one. Okay. So based on how much time it is taking, or what is the speed of the sedimentation of different RNA molecules, they are given some number. So this number is what we call sedimentation coefficient. So here this it is the formula, velocity divided by omega square r. So now when you measure the velocity of the particular analyte, okay, and you put all this formula, so it gives you a number. That is what is called Strindberg's constant. That means if you use the 16S ribosomal RNA, okay, and you centrifuge in a particular speed, so what will happen? If you you measure the speed of the this RNA, if you measure the speed, okay, and then omega square r is already known to you, then you will get a value that it will be 18. So you call it 18S ribosomal RNA. Okay. So this I have already discussed. More massive particles of the molecule tend to move faster than the less massive one. So it is because of this one, the first 2 rp square, because more massive particles means their radius will be more. Okay, then denser particles move faster than the less dense one, because this is because of this one, the rho p minus rho m. Because if you have the less density, then that means this difference of the density of the particle and the density of the medium will be less. So the velocity will be less. Okay. Then denser solution, the molecule moves the molecule slowly. The denser solution. I mean, here what it says is that when you have a denser solution, suppose you have a big particle, but your this medium is also very dense. That means the density of the medium is more. So in that case, this difference will be less. So again, that will affect the velocity of the sedimentation. It will be less. Okay. Now, speed of centrifugation. So this is important for you, because many students, they make mistake over here. So the speed of centrifugation is expressed in terms of revolution per minute, which is normally called RPM. That means in 1 minute, how many revolutions is made by the centrifuge machine. This is called RPM, or revolution per minute. Then the second one is the RCF, relative centrifugal force. So I always recommend that you, instead of using the RPM, always go for the RCF. So this is what I have already said. Now RCF is expressed as times G, this way. Okay. So the relationship between the RPM and RCF is through the radius of the rotor. So you see, this is the RCF, relative centrifugal force, and this is the RPM. So this is the relationship between the RCF and RPM. Okay. So the RCF and this RCF and RPM relationship, it goes through the radius of the rotor. Okay. So that means what we mean is that, see, if you take two different centrifuge machine in our department, okay, in one centrifuge machine you have a smaller radius, in another one you have got a bigger radius. Okay. Now when you have when you do the centrifugation in the centrifuge machine having the bigger radius, with this value, this R will be more. Okay, in this, and RPM is suppose same, constant. So in that case, the RCF will be more, because RCF depends on the RPM as well as the this radius of the rotor. Okay. Now what is happening is that when you use two different centrifuge machine having different radius, okay, and you are using the same RPM in both the centrifuge machine. Okay, RPM is same, but remember RCF will be different. The centrifuge machine where you have a bigger radius, so there what will happen, RCF will be more. RCF is the relative centrifugal force. It is talking about the force. So when you take a bigger, this happens, say for example, for precipitation of the blood for separation of serum or plasma. Okay, so in one centrifuge machine which we have in our department, the smaller one, if you put the 2000 RPM, So the blood cells gets separated and you can take out the serum. We have another centrifuge machine. If you use the same speed, 2000 rpm there, what will happen? The blood cells will be lysed because the RCF, because the amount of force that you are giving to the blood cell, it will be very high. So in that case, what will happen? The blood cells will lyse, and also your serum should be straw color. In that case, the serum will be red color because of the lysis of the blood cells, RBCs. Okay, so because of that, you should always look into the RPM. In both of our centrifuge machine, we have two readings. I mean, two methods how we can centrifuge. One is the RPM, one is the RCF. So instead of setting the speed of the centrifuge in terms of RPM, you use the RCF. Okay, fine. So if you use the RCF in the either this or the bigger one, so in both the centrifuge machine, okay, you won't have any problem. Okay, you will find that here when you're adjusting the RCF, so for blood we use the RCF of 2000 times G. Okay, so if it's a smaller one, you put the RCF of 2000 times G, and the bigger one you put the RCF of 2000 times G, no problem. Okay, because the bigger one, when you put the 2000 times RCF, so the machine will automatically reduce the RPM and you will adjust the RPM as per the RCF. Now, there are few problems here. Every machine do not have RCF. Okay, say in our department itself, the third centrifuge machine which we have, so there what happens? Only you will find RPM, you will not find RCF. Okay, so in that case, what to do? So in that case, you take out the manual of the centrifuge. So every centrifuge machine or every machine, whatever comes to your department, whatever is there in the department, you ask your technician to give you the Xerox copy or the original copy of the manual. Okay, in the manual of the centrifuge machines, you will find a graph. Okay, so something like this. So you get a graph like this. Okay, so in that graph, something like this. Here in the x-axis, you will find RCF, and in the y-axis, you will be having RPM. Okay, and then they will some kind of this kind of graph will be there. Okay, so something here, say 1000 RCF, 2000 RCF, 3000 RCF. Likewise here 1000, 2000 RPM. Okay, so based on that, just find out that how much RCF you require. Okay, then this much will be the RPM. Okay, so that will be the better one. But in some manuals, they don't put this kind of graph. What they put the table that this much RPM, this much RCF, this much RPM, this much RCF. Okay, so using that one, you find out that I need 2000 RCF. So what will be the RPM? Okay, if nothing is there, you don't have any access because many times what happens, people don't have the access to the manual. So because the centrifuge machines are very old. Okay, so in that case, the manual is lost. Okay, so in that case, the another way is that just where is that one? So in that case, okay, you use this particular formula. Okay, so you just measure the radius. Okay, or else if in the manual, if you find the radius of the rotor, then from that also you can find out the part that I want this much RCM, then what will be the RPM? You can find it out. Okay, or else if the radius is not there in the manual because manual is lost, so just using this ruler, you can measure the radius of the rotor. You measure it. Okay, then you put it into this formula. Okay, and you can find out that for this much RCF, what will be the RPM. Okay. Okay, now there are two modes of the centrifuges. So modes means there are two aim there because what is the aim of the centrifugation? There are two types. One is the analytical, one is preparative. So mostly we do the second one, preparative. So analytical means it is used for determination of physical properties of the analytes such as molecular weights, densities, etc. So I've shown you the Schwarzschild constant. Okay, So now supposing that you have a different RNA molecules of different size, and you want to determine what is the density of these RNA molecules. That is 16S rRNA, 18S rRNA, or 23S rRNA. So in that case, you go for the analytical centrifugation. Okay. So here, what happens? This is a special type of scientific machine which is not there in our department, or is not there in our college also. I think it must be there in the IIT and all. So here, what happens when you do the centrifugation? Okay. So these molecules, their velocity is measured by a detector. That means these tubes, they used to have some kind of just like some kind of camera system, or some kind of you can say kind of detection system is there that measures the velocity at what velocity the particles are moving. It can calculate the velocity. That is for analytical centrifuge, which commonly we do not do. This is mainly done by the people of the basic science. For veterinary science or applied science, it is not used generally. Now, preparative one, this is commonly we use. So, used for separation of the analytes based on their relative densities. So, you see that you have a mixture of the sample where you have different molecules having different densities. Okay, then you do the centrifugation. Now, based on their relative densities, these molecules will separate. Okay, I have already shown you that molecules having higher density will move faster, and molecules having lower density will move slower. It is just like your SDS page or that agrogel electrophoresis. There, what happens? The molecules, they move based on their size. Small size move faster, large size move slower. But into the centrifuge machine, it is reverse. The large size move faster. Large size means it is not linked to the size. You may be having large size, but thing is that the density may be less. So here, the separation is based on the density of the particles. Some particles are there having very large size, but the density is less. And some particles are there smaller size, density is more. So here, the based on the density, the particles are separated. Okay, just like for example, you want to separate the serum. Okay, you have collected the blood. Okay, now just after collection of the blood, say you want to separate plasma, not serum, separate plasma. So in that case, you have taken the blood in the anticoagulant. Now you will do the centrifugation. So that's how you just your blood cells got separated, and you took out the serum. Plasma. The another thing is that, say those of you who will be working in the virology. So if you want to purify virus, so what happens? Viruses, they are small particles. If you go for centrifugation, the difference in the density of the viral particles and the medium, that is water, it is very, very less. That's the difference. Of course, the virus have higher density than water, but this difference is very small. So it will take very, very long time to separate. Okay. So in that case, what we do, I'll show you in the next slide. So there, what happens? We use the density gradient. So we put some gradients, okay, in which the virus particles will separate based on its density. I'll show you in the next slide. So there are different types of centrifuge machines. One is a small bench centrifuge machine. So a small bench with this kind of machines, it is kept on the bench, on a table. Okay. So the small bench centrifuge machine, so generally they can accommodate, say, 10 tubes or less tubes, and the volume they can accommodate is about 1.5 to 2 ml. Okay, large capacity centrifuge is a large one. Okay, so here the maximum capacity they can handle is say about 500 ml maximum capacity. Okay, then thereafter we have the high speed refrigerated centrifuge machines. Now you see the high speed centrifuge. Now when you sometimes what happens, we use a centrifuge machine where the speed of the centrifugation is very high, or the RCF is very high. When you have very high RCF, so high RCF will generate a lot of heat because it requires a lot of energy. Okay, so when it is when the rotation is very fast, very high. So in that case, what will happen? This will generate heat, and your sample, the temperature of your suspension will also increase. So in that case, this will destroy your sample. Say for example, you are working on the proteins. Okay, your proteins will get destroyed. Okay, or you want to separate antibodies. So antibodies will get destroyed. Antigen will get destroyed at high temperature. So for that, we have the high-speed refrigerated centrifuge. So these centrifuge machines, they have the high speed, and then they have a facility for refrigeration. That means they maintain the temperature at 4 degrees Celsius. Okay, so the samples are okay now. Then we have the ultra centrifuge. So here, then the RCF is more than 100,000. That means when the RCF is more than 1 lakhs, so it is, so they come under ultra centrifuges. Small bench I have already discussed. So here the RCF is 5000 G, and they can, this already explained, about 70 ml like that. Okay, high speed. So, okay. Now this is what I was about to explain, the density gradient ultra centrifugation. Okay, so here there are different types of density gradient. So one I am showing here is the cesium chloride or sucrose. Okay, so here what happens, this cesium chloride or sucrose, here the density of the medium is not uniform. Okay, I can show you here. Say for example, say this is the tube, okay, where we have put the this density gradient medium, sucrose or cesium chloride. So here what happens, you add the sucrose. Say for example, you have added one sucrose solution having very high density. Say, yeah. So you added a sucrose solution of very high density. Up to this, you have added sucrose solution. Okay, so this sucrose solution has got very high density. Okay, now over that, you have added another batch of sucrose solution of less density. Okay, so over this, the same sucrose solution, but here the concentration of sucrose is less. Okay, when the concentration of sucrose is less, means here the density of the sucrose will be less. The medium will, because the density of the medium also depends upon the concentration. Okay, then thereafter again over this you have poured another batch of the sucrose solution where concentration is still less. Okay, the concentration is still less. Okay, fine. So now this I am putting different colors, but this is the same sucrose solution having different densities. Okay, so likewise I have again I have added another batch of sucrose solution having different density. Okay, so likewise I have okay, let me finish off this diagram. Okay, so now let us assume that this tube is full of the sucrose solution or cesium chloride solution having different densities. Now, one question you may ask, that here I have added the sucrose solution of more concentration. Over there, I am adding the sucrose solution of less concentration. Why these two layers do not get mixed? Because they are same sucrose. This is the important property of the sucrose and the cesium chloride solution. These layers of different concentration of the same compound, okay, do not get mixed because of the high surface tension. Because this layer, it has got a particular surface tension. Okay, this surface tension is high. That is why these layers will not get mixed. All of these layers, they will not get mixed. Okay, now to this you add the viral suspension. Okay, say let us assume that So these are the viral particles. Okay, so they are suspended in this solution. Okay, fine. Now when you will start the centrifugation, now what happens, these particles, they will start moving towards this direction, they will start moving towards this direction. Okay, now you see here what will happen, these viral particles, they will let me draw it in another simple way. So these are the viral particles, simply they are suspended here and there. Okay, now once you start the centrifugation, these particles, they will move in this direction. Okay, now the velocity of this viral particles, it will depend on the difference between their density and density of the medium. Okay, now suppose the viral particles are here. Now here the density of the medium is very much less than the density of these particles. So these viral particles, they will move from here to here. Okay, so here the density of the medium is increasing. So now they have reached a zone where density is little bit more. So now what will happen, the density of the particle and the density of the medium difference is less because it is more dense. Okay, so now in this region, the velocity of this viral particle will become less. Thereafter, these particles will move to this region. Okay, fine. So here in this region, the density is still more than the earlier one. Okay, now the density of this medium, okay, it is more than this one. Now what will happen, the density of the viral particle is still more than this medium. So but since the difference is less, so velocity will become less. Now they reach here in this zone. Okay, now in this zone, the again this green zone of the sucrose or sodium chloride, the density is more than the red one. So here what will happen, supposing that the density of the medium is equal to the density of the particles. Okay, so the density of the medium is equal to the density of the particles. So what will happen, if you just see here, this value and this value, if they become equal, then as a whole this V will be 0. That means when they will reach in the green zone, where this particular region of the sucrose or sodium chloride, the density is equal to the density of the virus, so the viral particle will stop moving. Okay, so once you stop the centrifuge machine, so you will find that these viral particles, they have concentrated at this green zone. They have concentrated here. Okay, see earlier these viral particles are uniformly distributed, but now after centrifugation, now they are concentrated at this region. Okay, now thereafter what is done, one hole is made here. So some kind of hole is made here. Okay, now through that hole, these viral particles, they are extracted, they are purified. So this is how you have concentrated the viral particles. Okay, so this is what this is an example I have given you about the density gradient ultra centrifugation. Okay, so the density gradient, always we go for ultra centrifugation, because here what happens, the density of the virus is not very much different from the density of the medium. Okay, so that is why only way to increase the velocity is to increase the speed of centrifugation, and that you can do only in the ultra centrifugation, where RCF is more than 1 lakh. Okay, so same method is also done to purify different organelles. Say mitochondria is there, then mitochondria is there, then this Golgi apparatus, ribosomes. When they separate these organelles, so they use the ultra centrifugation, density gradient ultra centrifugation, because all these ingredients, all these organelles, they have got different densities. Okay, but of course we don't do this here. So this particular density gradient ultracentrifugation, it is done by some people to purify viruses. Now the types of rotors you have. The rotors means they are the rotors where you will keep your sample. So there are two types of rotors. So one is the fixed angle rotors and the swinging bucket rotors. Okay. So fixed angle rotor means in the first one I will explain first. This is the swinging bucket rotor. So here what happens? This is the place where the centrifuge tubes are kept. So the place where centrifuge tubes are kept, these are hung over the this rotor. So once you start the centrifuge machine, so it will just it will fly in this way. Okay. So this kind of swinging bucket rotors is used mainly for density gradient centrifugation. Then you have the fixed angle rotors. So in this case, this angle is the fixed. That means this is the place where you will keep the centrifuge tubes, and this the angle of this rotors, it is 45 degree. So this one is a 45 degree angle. That means the centrifuge tubes are kept in the 45 degree. So this kind of fixed angle rotors are good for precipitation. Okay. Say you have a DNA solution and you want to precipitate the DNA. So once you start the centrifugation, the DNA will precipitate in the bottom of the tube. This is what is. So for precipitation, the fixed angle rotors are used. So in our department, we do not have the swinging bucket rotors. We have only the fixed angle rotors, because most of the things we can do it here, because we don't do the this density gradient centrifugation. But if you want to do the density gradient centrifugation, that is ultra centrifugation, you will have to go to the Guwahati Biotech Park. So there the ultra centrifuge machine which is there, so that is the of swinging bucket rotors. So okay, so